Reda Vijay, you mentioned about the predictive maintenance module.
Sir.
And how did your MRO setup exactly utilize the condition-based maintenance or the predictive maintenance module? Could you throw some light on it?
Yes. So we had, for the condition-based monitoring system, we had done that only on the mechanical drivetrain. So we already had sensors on the fleet which recorded what is the temperature. These were on the main bearings, on the low-speed shaft, on the intermediate shaft, and the high-speed shaft. It was also on the various elements of the gearbox. So the temperature sensors were there, which was inbuilt as per the design of Suzlon. We had sensors which monitored the oil level, as well as sensors which monitored the amount of metal in the oil in various places. We added sensors which measured vibration. So vibration along the entire drivetrain was measured. So our condition-based monitoring system was getting this data through the SCADA at the Suzlon Monitoring Control Center. And here we had hired an external team who were experts on CBM, who were analyzing this data and finding out where are the outliers, where is there likely to be some fault on the drivetrain. And this data was every morning in the plan of the day sent to the sites. So the site team will go and physically investigate that is there a problem with the sensor, or is there a problem actually with the machine, and the data coming is having an issue. As far as predictive maintenance goes, sir, we were getting data about the gearbox. We were getting data about the main bearing, the pitch bearing, which was where we were monitoring the current. There's a separate pitch bearing for each of the three blades. So we were getting the electrical consumption along the three pitch axes and on the generator. So on a particular site of 60, 70 wind turbines, we would catch those top three variants, outliers in terms of high temperature, in terms of high vibration, in terms of high electric consumption or low generation as part of our predictive maintenance capsule. And it will go to the site along with a checklist of these are the aspects to be checked. So they were able to predictively go to the turbine and find out if there's a problem which is likely to come up. Now, in the wind industry, for supposing a gearbox or a blade has to be changed, the effort involved is massive. The gearbox weighs something like 80, 90 tons. It is at a height of almost 150 meters at times. And you have to hire large cranes, and to position a crane, it can take us 30 to 45 days to get a crane into place. Plus, you have to take a lot of clearances from the various authorities to move such large plant and machinery. So with the help of predictive maintenance, what we were able to do is we were able to move this plant and machinery in advance, make it reach the turbine, and then take a turbine shutdown. So that saved us immense amount of money, as well as prevented turbines from being shut down for long periods waiting for plant and machinery. And it made a dramatic change to our machine availability as well as to the profits that were coming in.